Today we're going to talk about light and energy. And light is a type of energy that we're going to talk about. We are going to talk about a lot of different types of energy throughout this course, light being the first one. So when we think about light, it has a bunch of different properties. The first one is that light can act like a particle or a wave, and we call that property wave-particle duality. The next thing that we need to know is that light will always travel at the speed of light, which is 3.00 times 10 to the 8th meters per second. It does not matter the type of light it is, so it can be visible light, it can be X-rays, it can be gamma rays, it does not matter the type of light, it will always travel at that speed. What does change, though, is the frequency, wavelength, and energy. And it's the wavelength that's going to tell us the type of light that it is. Let's talk a little bit about how light is produced. So an electron will be hit with energy. There's a few different ways that an electron can be hit with energy, but one of them is by heating it up. And so if that electron absorbs energy, it will go to something called the excited state. And the excited state just means that the electron is at a higher level than where it started. Now, when in an excited state, the electron can't really stay there for very long. It can't hold on to that new energy because it wasn't supposed to have that energy in the first place. So the electron gives it off in the form of light. Now, when the electron gives off that energy, it can't stay at the higher energy level anymore because it's now in the wrong energy level for the amount of energy that it has. So it goes back down to the ground state, and the ground state was the lowest energy level, that energy level that that particular electron started at. So let me give you a visual of what this looks like. So here we have a Bohr model of an atom, okay? And let's say that we have an electron starting on this second energy ring. Okay? Something hits this electron. Okay? So we have energy that is hitting this electron. And because this electron absorbed energy, it has too much energy to stay on that energy level. So it jumps up to what we call the excited state. Depending on the amount of energy that it gains, depends on the energy level we'll go to. But let's say it goes to this outer ring right here. We're going to call it the excited state. Well, this electron now has more energy, but it can't hold on to it. So it gives off the energy in a form of light. Okay? And then once it gives off that energy, it goes back down to its ground state. And that's how light is produced. Now, when we think about light, we're going to talk a lot about the relationships between wavelength, frequency, and energy. So our wavelength is how long a wave is. So if this is a wavelength of light, we are going to think of the wavelength as being from crest to crest, the distance it takes to go through an entire wavelength. Okay, and it is measured in meters. Okay, frequency is how often we get through that wavelength. So it's going to be meters per second, how often we get through that wavelength. So here I have two different waves set up for you. So when we look at this first wave, this right here is going to be our wavelength, and this right here is going to be our wavelength. So we would say that the wavelength is longer for the first one, and the wavelength is shorter for the second one. Now, when we think about frequency, remember that is how often we can get through the wavelength. So because this is a shorter wavelength, we'll be able to get through it faster, right? We can get through 2.5 wavelengths by the time we get through one here. So this one's going to have a higher frequency, and this one is going to have a lower frequency. So that means that, I'll write it over here. Oh, you can't see it over there. Wavelength and frequency have an inverse relationship, meaning that as one of them gets larger, the other one gets smaller. Okay? The last thing that we need to think about is energy. Well, something that happens more frequently is going to have a higher energy. So this one happens more often, so it has higher energy. Think about things that move fast have more energy than things that move slow. This wavelength is going to be moving, it's not that it's actually moving slower because they all travel at the speed of light, but it happens less often. So this one's going to have a lower energy. So now we want to create our relationships for energy as well. So we already know that wavelength and frequency have an inverse relationship. Now, if we think about frequency and energy, for our longer wavelength, they are both lower, and for our shorter wavelength, they are both higher. So that means that these will have a direct relationship, because as one goes down, the other one goes down, and while one goes up, the other one goes up. We call that direct. Okay, and the last thing that we have to compare is wavelength and energy. So wavelength is longer, energy is lower, or wavelength is shorter and energy is higher. So that means that it's going to follow an inverse relationship. So an inverse relationship is also going to be wavelength and energy.